Hello everyone. Welcome to my YouTube channel. In this video, we will discuss about centrifugal pump. Like, what is the characteristic curves of the pump? What are affinity laws for the pump? So let's see, what is the characteristic curves of the pump? So the head capacity curve is called the characteristic curve of the pump. The characteristic curve is used to express the performance or operating characteristics of any particular pump. The figure shows the operating characteristics curve of a pump, where the head H, power P, and efficiency eta is plotted against the discharge rate or capacity Q. For that, tests are performed for pump under varying conditions, and the results of such tests are plotted. Because a pump is usually designed for one particular speed, flow rate, and head. But in actual practice, it may be operated at some other conditions of head or flow rate. Hence, the behavior of the pump may be quite different for the changed conditions. So the characteristic curves show head, power input, power output, and efficiency as a function of discharge rate or capacity for a particular centrifugal pump at a particular speed. Hence, we can say that the characteristic curves of a centrifugal pump are the graphical relationships between head and discharge rate, efficiency and discharge rate, and power input and discharge rate at a given speed. So from the characteristic curve, we can see that the HQ curve shows the relationship between head and capacity or discharge rate. So from HQ curve, we can conclude that the head decreases continuously as the discharge rate or capacity is increased. Then eta Q curve shows the relationship between pump efficiency and capacity. It is clear from eta Q curve that efficiency rises rapidly with discharge at low discharge rate, then reaches a maximum in the region of the rated capacity and then falls. But the head, at first, falls slowly with Q, and eventually falls off rapidly. Hence, the optimum conditions for operation are those at which the point where the head curve cuts the ordinate through the point of maximum efficiency. This point A is called as the duty point. The values of head and discharge rate corresponding to the maximum efficiency are known as the normal or designed head and normal or designed discharge of the pump. The head corresponding to zero or no discharge is known as the shut-off head of the pump. So from HQ curve, we can determine whether the pump will handle the necessary quantity of liquid against the desired head or not, and the effect of an increase or decrease of head. Then the PB versus Q curve gives us an idea regarding the size of motor, that is power required to operate the pump at the required conditions, and whether or not the motor will be overloaded under any other operating conditions. And the PTQ curve gives us an idea regarding power delivered to the pump versus discharge rate. The difference between power input and power delivered to the fluid represents the power loss in the pump. This has happened due to fluid friction and shock losses, leakage, disc friction, and bearing losses. So from this figure we can see that the actual head is less than the theoretical head. This difference is called as head loss. The factors responsible for the head loss are circulatory flow of liquid, fluid friction in the passages and channels of the pump, and shock losses from the sudden change in the direction of the liquid leaving the impeller and joining the stream of liquid traveling circumferentially around the casing. Now next question. What is affinity laws? So the relationships of impeller size and speed to capacity, head, and power are called the affinity laws. So when a complete set of performance curves is not available, the characteristics of a particular pump can be predicated from a similar pump, and the theoretical equations for an ideal pump. So table shows the affinity laws for the pump, where d is the diameter of the pump and n is the impeller speed. So these affinity laws are useful when an existing pump must be modified to give a higher or lower or different capacity. Then the changing the impeller size or speed is often less expensive than buying a new pump. So that's all about the characteristic curve of pump and affinity laws. In the next video, we will see another topic related to pump. The link of the videos. Working of centrifugal pump. Advantages and disadvantages of the centrifugal pump. Components of a centrifugal pump is given in the description box. If you like my video, please like, share, and subscribe to my YouTube channel, which is ChemicaladDa.